My name is Joseph T. Wunderlich. I'm Professor of Engineering, Architecture, and Computer Science. I will go rapidly through these slides, and then you can come back later and look at it. If it's on YouTube, there'll be a PDF underneath in the comments. Some of the sources, and plus my experience. Adjacency is very important in architecture, both for the functional reasons and symbolic reasons. The degree of visual and spatial continuity depends on the nature of the plane that separates and binds them. The type of connection between the spaces helps define the adjacency between the spaces. Spaces relate to one another by function, proximity, or a path of movement. Adjacencies can be defined by a space within a space, interlocking spaces, adjacent spaces, or spaces linked by a common space. Let's take a look at spaces linked by a common space. And here you can see the space finding the connectivity between these two spaces, the loggia in the middle, connecting the temple on the left and the community space on the right. And here is a video log of the temple, part of a video lecture. Frank Lloyd Wright, 31 sites that I visited with my son in and around Chicago, Oak Park, River Forest. You can see the model down low. This is taken in the loggia, which is the connecting space between the temple and the community space. Also in the connecting space here down underneath. The main gathering space, the balcony up above, the temple, the roof of the temple. This is St. Maria del Salute in Venice, Italy. This is my son in the foreground here in 2011, or 2014. Went back again with a wife and daughter in 2017. You can see the form here and the hierarchy of spaces. Here's an original drawing of it, seeing the central space and the organizing spaces around it. You can see here how the spatial relationship from overlapping spatial fields, making a unified space. This is the Pantheon in Rome. The defining space within is a sphere. Also some regulating lines with the sun coming through the oculus, the hole in the ceiling. Regulating lines you can see in the shapes, how they relate. It's another example of a sphere within a square and how that space is defined. This is Thomas Jefferson's Monticello in Virginia, his home, inspired by the Pantheon. This is the Guggenheim Museum by Frank Lloyd Wright in New York City. Centralized organizing space, circular space. Here's another chapel. It's a church, a chapel in Florida. Triangular shapes. The ceiling plane and how that defines the spaces below. This is a vaulted ceiling, defining a space, or also a place where you can put frescoes. Here's a barrel vault in Frank Lloyd Wright's home and studio, made for his children in an addition. Here's a vault in Windsor, England, in a boarding school, boys' boarding school turned into a hotel we stayed in Old Windsor. Barrel vault. Here's a groin vault. This is in Padua, Italy, Padova, Italia. Here's a project of mine in Pennsylvania with a ceiling I raised up. There's a before and after, ceiling pretty much caving in, raised it up. Here's another part of that building. Skylights defining the overhead plane in a nice way. The openings, it's positive space. letting the light in. Interior and exterior views. The structure of the building itself helps define the shape of the ceilings and the walls. These are slides from earlier lectures on the structure. Some of these structural members you might want exposed, some maybe not. Here's a case where you might want it exposed, the glue lam. More glue lam, heavy timbers. Here's some place where you probably don't want it exposed. This is my project in Pennsylvania. I'm putting an old 150-year-old farmhouse connected to a new addition. Here's defining a canopy above over top of a shopping mall and closing it but letting the light in. Here's some more pictures of how you can use your ceiling plane. Now the floor, sunken floor, defines space. Nice sitting area around a fireplace. TV, watch TV also. Some details, you come back and look at this, of flooring materials now, getting into the specifics of how to put in wood flooring and how to specify it as an architect. Terrazzo flooring, terrazzo. Difficult to do if you haven't done it before, or even if you have. So the facade, or most of the elements here you see are inspired by the foible blocks he played with in his youth. These are the interiors. That's what we're talking about mainly here. You look at the fine woodworking, the fine details, the inspiration of geometries throughout. The breaking up the box, the open floor plan, and the exterior shell, taking out the corners. Again, it's the dining room. This is the bathroom, very innovative way of letting light in. Here is the master bedroom. Children's room with a partition down the middle, similar to what you see in Japan. This is the studio space with a quote by Rudyard Kipling saying that we'll build the perfect ship. Here is the playroom addition with a woodblock inspiration. Fireplace. A balcony for when the children would perform. People could sit up there and watch. The piano in the wall also. Grand piano extends over the top of the stairwell. And there's examples, some foible blocks. Some architecture theory, the harmonious relationship, magnitude, quantity, or degree of one part to another, or to the whole, magnitude, quantity, and degree. Also regulating lines that are parallel or perpendicular to each other, and how they control the proportion and placement of elements. Now taking a look at the Roby House and seeing perhaps some Japanese influence there. And you can decide for yourself. So the open floor plan is demonstrated here in this design. Frank Lloyd Wright pioneered that in America. It's from another angle. You can see this is the living room area, and it wraps around right into the dining area, and you can see through above the chimney right to the dining area. Picture of me, this is actually the downstairs of the Roby House. Here is an open floor plan of a present-day home inspired by the Japanese Engawa, which we'll take a look at in another part of this lecture. So this is Gustav Stickley. Now, green and green, this is a famous design in Pasadena, California. The big open windows and woodwork, fine detail, and good craftsmanship everywhere. Furnishings and the woodwork of the building. It's the kitchen area. The details of the steps. This is very reminiscent of architecture or carpentry in Japan. Stairwell. Upstairs. Bedroom upstairs. Front door. I found this picture. I don't believe it's in this house of green and green. It looks like an inspired design from green and green. Regular composition of regular forms. Pinwheel. Cruciform. Now into some materials. If you're going to make fine craftsmanship, you should understand your wood. And so the surfacing of wood, rough sawn versus surface wood, and the designations of them, the dimensions, the grades, the quality, relative qualities, hardness grade for flooring, and walk on it. Repurposing wood. If you're going to be sustainable and you care about the earth and the resources, or you just want to save money, it's green is good. Not greed is good, green is good. Make more money by saving and repurposing wood. So this is from my 150-year-old farmhouse. We made some furniture. My son actually designed this. He designed this table and made this table. That's our kitty, little miss. My daughter wanted to help, so she wanted to paint. You can see the repurposed wood in the background, and she's helping. Before and after this project, did all the work myself. Only thing contracted was the shingles on the roof and the concrete mix truck. My son and I did this. Some model alternatives. The interiors, we're talking about interiors here, so that definitely played a factor in which design I chose. You can see here that the interiors are driving the decision process here of getting more space and spreading out, raise a family. So that was the main criteria, even though the shell and how it complemented, the addition complemented the existing structure, both the vernacular of the existing building and the area and neighborhood, the context of this Amish land. So you can see the two upstairs and downstairs of the house, 2 bedrooms upstairs, living area downstairs. Just an example floor plan and section drawing from this book we've been using for a number of lectures. For example, visual scale refers not to actual dimensions, but to how small or large something appears in relation to its normal size, or to the size of other things. We speak of a human scale, and we want to keep things at a human scale. Frank Lloyd Wright was very good at that. Actually a little smaller than most human scale because he was not very tall, but still nonetheless a human scale. And amongst the modernists, he was not a typical modernist in that respect. Certain elements that you put in your, as well, furnishings as well as the architectural elements can define the scale. And stairways, for example, windowsills. Typical stairway, the size of the steps and the length of the treads. Terminology for stairs, risers, treads, stringer. Here's all marble stairwell, or stairway, a picture I took in Rome 2011, the Vatican Museum. Defining space, so the walls and how they define spaces, and the wall and the floor together. Also a cascade of columns will define a wall. A wall can be a passive or receding backdrop, or it can assert itself, accent wall. A couple examples of accent walls. Make a statement. Accent walls. You do it just with a texture or bold color, or both. It helps define the space. Now the wall plane, this is an example project of mine in San Diego, California, a Calavita residence. It's actually a professor of mine from Italy in urban design and architecture history. So I made a little model of wall planes of the house. Show a couple pictures of renovated parts of the kitchen and bedrooms and other areas, but they're not shown in these pictures. They're shown the walls here. I made a curved wall coming in. I rebuilt the whole, put that new door in, and the side light, all the woodwork. Built this wall with a bench and shelving. Built around the fireplace. Defined a space, a sitting area with the walls and a curved wall. Some of the specifics of how to install, this is drywall being manufactured. Now this is different parts of the country, and different people will call it differently. You see in the diagrams here, referred to as gypsum board. It's also drywall, sheetrock, wallboard, gypsum board. All those will work in most building supply places, most places in the country. There's curving, different techniques of doing that. You can wet it down, you can score it, just get the thinner 1/4 inch, and it bends a little bit on its own without, to a certain degree. Taping and floating, or called mudding in some areas, with a reinforcing, joint finishing, is an art as well as a science, and if you haven't done it before, it pays to subcontract somebody. Especially if you have tall ceilings, because it's not an easy task to be up on stilts. I have not used stilts. I use scaffolding if I need to get up high. But if you do drywall, tape and floating plastering for a living, then yeah. Different terminology, the hawk, and then this is plastering now, which is similar to drywall joint mudding, but a little different. Say there's a scratch coat and a brown coat. You do it in layers. This is, my son took this picture in Venice, but it reminded me of, I stayed in a monastery once in Rome, and I just watched for hours somebody plastering a groin vault ceiling like this. They were in no hurry, and I was in no hurry. Some specifics about what you can do with drywall. Wall sections is you can regulate the sound transmission coefficient. There's different ways of doing that, putting insulation in the wall, and the air gap, and several layers of sheetrock. You can change the sound transmission. These are plaster walls that were finished by my daughter by herself in here, and then there's another room my wife did by herself. Quite a bit of work to get a really fine finish, and all the woodwork also painted, several coats, and the floor. Here's a quick and fast way to build construction now that you see in a lot of other countries, even in the United States, some giant wall sections prefabricated in the shop. Talk a little bit about bathrooms now. So I'm going back in history again, looking at the ancient baths. The Roman Empire was a social gathering place as well as for cleanliness. This is Emperor Caracalla, baths, public baths. That's what it looks like, what's left of it, the remnants. Fast forward to today, walls and glass block walls help defining a nice space, letting light in, but not so that you can see people in there, but just letting the light in. You can do some very nice things with glass block. I plan on trying this sometime very soon in one of the bathrooms. Now we're going to talk about the scale, or the rhythm and the design theory around how you lay out your floors, and you could lay out the face of buildings like this too. But there's the golden section, the golden ratio, an ideal relationship that's gone down through history is a known proportioning of space sizes, you can see here, and look at the way they relate here. Now, in Renaissance theory, there's certain ideals of what a room layout should be. You can take a look at that. And the heights, too, and proportions. Arithmetic, geometric, and harmonic. Come back and take a look at that. Modular. This is by Le Corbusier in France, and his way of doing things. He had a whole methodology and proportions of his own, applied it to his buildings. You can research that as a whole topic. Ken in Japan is a way of doing that, and they use a certain unit of a tatami, which is the mat, which is a certain size, and that defines a lot of how the spaces are. That's a unit of measurement that they use. So you see a 6-mat room, or a 3-mat, 4-mat, 4.5 mat, and so they're units, they're mats, the tatami mats are defining the spaces. Just a couple elevations. Anthropometry refers to the scaling things to the human proportions. So while the architects of the Renaissance saw the proportions of the human figure as a reaffirmation that certain mathematical ratios reflected the harmony of the universe, anthropometric proportioning methods seek not abstract or symbolic ratios, but functional ones. So you'll see this in the Architectural Graphic Standards. It also drives what the ADA, for American Disabilities Act, recommends for people in wheelchairs, and disabilities, and just people without disabilities too, how you function and the ergonomics around the furnishings and the egress, and how you maneuver around in a building, or even in a crawl space or a pipe or an attic. What are the human dimensions? And so you can apply this in an architectural aesthetic context as well as functional. Considering proportional constraints on a form by materials or structure, the designer has the ability to control proportion of forms and spaces. So you can extend a room, make it lofty, up. You can go out and up, or define in different ways. If you have a large, massive thing overhead, an overhead plane, can appear or feel like too much for the supporting space below. So you want to proportion carefully. This is not literal weight. This is the weight of the magnitude of the space. So defining spaces, the corner can be an independent element that joins two planes. And you can play with where the openings are. So Frank Lloyd Wright wanted to destroy the box and open up the corners. So the way you lay out your windows, where you put them, and also where you put skylights and how they open up can affect the space quite a bit. Do take the time to come back and watch this little video here about, as walls opening, increasing in size, views become part of the spatial experience. So the merging of the interior and exterior is a common thing in Gawa of the Japanese architecture, the exterior hallway that they use and don't use different times of year for different purposes, and it penetrates the outside and brings it into the inside. So Frank Lloyd Wright, destroy the box, remove typical walls, open it up, open it up. This is in falling water. Doesn't even seem like there's a corner there, or even glass. Banding of windows. Now, I can't say I was thinking of Frank Lloyd Wright specifically when I did this, but I always knew this as a good principle. And, man, I had looked at Frank Lloyd Wright things when I was younger, too, so this is what I've done in my Pennsylvania house, looking out the farmland. Light and how you manipulate light makes a big difference in the space. The shifting patterns, how it animates the space, the color and brilliance of light, whether it's diffused or coming in directly, how it creates shapes, spaces, and color of its own, and bringing in the quality of the direct sunlight or diffused daylight varies with the time of day, season, and place. Humid areas will be different than dry areas, certainly different times of the seasons, different latitudes. I took this picture in the Vatican, in the cathedral, and you can see how that light is playing a role in defining the space. Some skylights that I designed in a house, you can get a feel for the light, how that's helping define that space. It's very dark in this room in the corner without any light on that side. This is the southern wall, and I had to put operable blinds because of that. Typically, you don't want to put skylights on the southern side, but it really needed light in here. So windows and skylights establish a relationship between a room and its surroundings. Now, your windows can establish a relationship with the outside and the surroundings. If they're in the second picture here, if it's a small opening, it can be somewhat like a painting on the wall. And the next, you see two pictures, and it can invoke a feeling of movement across the two images, two openings. And then the bottom picture, a narrow opening can separate the two planes, but also hint at what lies beyond without actually seeing it. So as you put larger windows in a wall, it opens up and expands the space, opens up the room to a broad vista. That scene can dominate the space, or it can serve as a backdrop for activities within. In the second image here, you can also have a private view by the placement of the window. And then the third image here, a bay window can create a space in itself to be occupied by a person. Now you see my Pennsylvania residence project here, where I'm framing vistas for the views out certain directions. You can see here capturing the views out into the farmland and up above, so we get the sky and the day and the night, see the stars. Now we want to look at some of the interiors of another Frank Lloyd Wright project. Visited this with my son in 2020. This is Taliesin West. There's the original Taliesin is in Madison, Wisconsin, and then he lived and worked here, ran his school, his fellowship with his wife Olga for many years, and she ran it for over 20 years after he passed away. The fellowship still exists. It's a little troubled for a while, but it seems to be back in business now. The students travel from Madison, Wisconsin to Taliesin West. So from Taliesin to Taliesin West with the faculty, 6 months in each place. Here's the interior space. You can see it's somewhat of a triangular influence on the open floor plan, of course, and a very welcoming, comfortable space. We sat in here and got one of our short lectures from our tour guide, who was very, very good. This This is my son talking to the female students sitting there, and then the staff were hoping to recruit my son into a graduate program. They gave us an extra tour beyond the regular tour, behind the scenes, and in the residential area. They live out in the camp. There's a story behind that. The students each make their own dwelling in the desert. This is a project I did when I was 16 years old, a regional design competition for municipal building, hexagon theme. This is a curtain wall. Does not carry any load. And the structure, the way the structure is made, is such that all the load is distributed and carried vertically down through columns and other places, so the exterior wall is free to be a curtain of glass. Then time in California. So Southern California, this was one of my projects. This was my main project for this particular developer, and so I coordinated all that, negotiated all the contracts. Now we want to talk more about the shell, the walls of the shell. And this is Shanghai Tower, which has a double-walled system creating a whole environment in between the walls. As you can see here in a section of the floor plan. You can see here that in commercial buildings and high-rises and even mid-range height buildings, in earthquake areas, you need this strong bracing or moment connections like you see on the right for lateral loads, earthquake loads, so that can certainly disturb the interior views and quite dramatically affect the space planning, although it's cheaper. $2 to $3 a square foot, developer terms. More expensive. Well, that was 30 years ago, so if to put that in today's dollars, 35 years ago dollars. And you see here what looks like in the commercial tenant improvements, it's called. So you build a shell, and then you look for tenants, and then you give them so many dollars per square foot, and they build out, and it's almost always steel stud like this. So it's specialty trade. You don't want to have your wood carpenters, no matter how good they are, try to do this. I learned that the hard way on a project, assuming good home builders could do this, and then they had trouble finishing. Also, if you have perimeter walls or the walls of your core or concrete block, you fur them out, metal furring strips, and then you can put your sheet rock or drywall or vinyl coated rock, different things you do in commercial construction. Fire resistance, you always want to be concerned with that in any building, but if you have a large occupancy to the building, this is a very important part of the building code. You need to get this past the fire marshal in your drawings, and you very much need to consider people being able to get out of the building and survive based on the fire ratings of the different materials, how long it takes for the fire to burn through. You also have sprinklered versus non-sprinklered classifications according to the IBC, the International Building Code. Now ceilings, we'll take a look at ceilings and floors here. And so this is commercial construction, ceiling grid, drop ceiling, creates a plenum space above so you can run your mechanical and electrical equipment above. It's very convenient in commercial construction. And there are, of course, quite a variety of ceiling tiles that you can get. Armstrong Industries is right down the road from where we are in Elizabethtown here. We visited there. They're actually lead platinum for O&M, but also very good for their building for sustainability overall. I judged one of the regional USGBC Green Awards there with fellow people in the architecture and engineering industry, mostly architecture. Some more commercial construction. Here's something you can do with some wood. There's all kinds of finishes. You want to look at the suites catalog and look at all the possibilities you have. Drag in your BIM information, building information, modeling information database directly into your Revit drawings, and it's very nice. In the old days, we used to look through big giant green catalogs 35, 40 years ago. Now it's all online and seamlessly connects with professional software, Revit, that we have in the lab. Carpeting here is just an example. This is wall-to-wall carpeting. It looks like glue down, which is a cheaper one. You could also do it over a pad, which is a little more expensive. Typically just do that in conference rooms or the main offices of the executives. You can do it all throughout in a small office too, but the glue down's cheaper and lasts longer. A couple other flooring choices. You can see slate, not typical inside the house. Marble, as expensive as you would imagine, but it can be very nice, certain applications. You know, in lobby areas, you might want to do some kinds of tiling, in bathrooms. The more detailed, of course, the more expensive it will be. Some basic construction details of how you might put down tile. Inexpensive, quick to put down kind of material is the vinyl. Sheet goods comes in rolls. Typically referred to as resilient flooring. You can see that resilient flooring is typically referring to a vinyl kind of thing. Here you have sheet vinyl. It shows some of the details. Also an epoxy coated floor, which is very durable for maybe a manufacturing facility, or you could be driving vehicles like you see here on the right. Now here's a very much a specialty item, but what I was most familiar with in buildings when I was, or the most computer related thing that I was familiar with in buildings before I got into computing as a profession. This is a raised floor where you run all of your electrical cables inside of IBM. When I got inside IBM, we're running all optical cables. You may also have refrigerant lines, electrical power, more importantly, just blowing air too. Get cool it, even if it's all air cooled now, as it is with the CMOS field effect transistor technologies. Everything's air cooled now. It used to be with the bipolar type transistors, you would have liquid cooling because it would burn much hotter. And that was the only way you could get speed in the old days. Most of the computer rooms were filled with cooling, air conditioning equipment to cool the computer down. Not so much anymore, but you still need a raised floor. And here's an early example of one that I was involved with in Texas. So I was project manager on for 13 buildings, including 2 IBM 360 computer centers. One was for a pharmaceutical company, and just finishing that one up when I got onto the project here and became the head of the project. And then from the ground up, built built a building for a computer company, fast-tracked it, got an IBM 360 computers in there. They were one of the first internet purchasing auto parts. It was a closed connection thing just to auto parts dealers. This is in 2000 or 1984, 85. It was quite a deal to get the power in there. Getting 100, they needed a certain amount of kVA, which is different than amps. That was miscommunication on the people who signed the lease and negotiated the lease. So I had to get trenched in special power, and then air conditioning was a special thing. This is all in the middle of August in Texas. quite an ordeal. And finally, you can see many projects of my architecture students on this link, and including virtual reality and Revit professional software integrated into most of the projects. Now,